Hey, hello everyone. Today's Liferay delivered dev.life session. If you don't know what dev.life is, it's a series of live online sessions delivered by Liferay. If you don't know who is talking to you, that's the tiny little guy here. And that's me. My name is Milan Yankov, and I'm developer advocate at Liferay. And I'm the host of this show for today. That doesn't mean I'm going to be the host for every single show that's going to happen in the future. But for now, I have the pleasure to introduce to you smart people that's going to talk to you about interesting technologies and teach you how to do interesting things. Before we start, though, all the stuff we discuss is related to one of the many Liferay projects that we have, and you can have a look at the community.liferay.com/projects to learn more about all the projects that we work on at Liferay. And also, if you want to be notified about future live sessions on dev.life, you can join our meetup. You see the URL on the screen. We do run our user groups as on meetups, so you can look around, see if there is a user group nearby, and join and actually have live meetups like in the real life, not only online. But anyways, dev.life is also a meetup, so sign up there to be notified about upcoming episodes. While you are watching this, you have two options to comment. One is the chat next to the video or below the video, depends on your YouTube setup. And the other thing is our Slack chat, link to which you have under the video, so you can join the dev.life channel on our Slack and comment and ask your questions, and I'll pass them to our guest, which today is Iacopo Colonnelli, who is an IT consultant and Aktive Reply. And he will be teaching you some interesting things about how to build stuff with Liferay Porto using Docker and not getting, and still being able to use things like debug and GoGo shell and gulp watch. But hey, it's Iacopo that knows how to do that. It's not me, so I'm just going to pass it to him right now. Hello, Iacopo. How are you doing?
Hey. Hello, everybody.
All right. I'm passing it to you now, so you can tell us how to do this cool stuff.
Okay. Thank you, Milan, for the presentation. I am Iacopo Colonnelli, and I will present you my work that I published a few weeks ago on Liferay blogs. And today I will basically talk to you about what Docker is in a really few slides. I will tell you what Docker is, why we should be interested in the world of Docker and the world of containers, and then I will play a live demo to show you how we can integrate Docker into Liferay Workspace and start using Docker with Liferay from the early development stage of our projects. So, just in case someone doesn't know what Docker is a container technology that allows us to build, run, and manage the life cycle of our containers. And probably, if you don't know what Docker is, the second obvious question that you would like to ask is, what a container is? A container is a set of processes isolated from the rest of the system, running from a distant image that provides all files necessary to support these processes. What does it mean? So let's start from the beginning. A container is a set of processes. So a container is a box in which we put a set of processes that run isolated from the rest of the system. This means that the processes we put into the box, the container, will run independently from processes running on other containers and processes running on our host machine. What can we put inside our container? We should put inside a single container only one application and all processes that we need to enable our application to work, no more than this. Additionally, we can choose the isolation degree of our container by deciding which network port he should expose to other containers, which portion of our host file system he should be able to see, and which percentage of our hardware resources like CPU, memory, and so on, he will be able to use, he will be allowed to use. But the main rule for container development is give to the container the minimal subset of permission it will need to, no more than this. And from a theoretical point of view, this concept is similar to a virtual machine environment, because also with virtual machines, we are able to build up an isolated environment that runs independently from the processes running on other virtual machines or on our host operating system. But from a technical point of view, the two technologies are really different from each other, because to run virtual machines, we need an hypervisor layer to virtualize the physical layer, and a guest operating system for each of our virtual machines. And this raises an enormous overhead that give worse performances, and running more than 3 or 4 virtual machines per single host computer is impossible, because we lack of resources. On the other side, with containers, we have a single host operating system here, because the kernel is shared among all the containers. Then we have a middleware, that is the Docker process that manages our containers. And then in each container, we can have only our application and no more than that. So we can easily run up to 6 or 7 or more containers on a single physical machine. In my company, we realized an environment with 6 containers running in parallel on the same machine. And so you can recreate also complex environments in your PC quite easy, in a quite easy way, and I will show later how to do that. But another important question that you can ask if you don't know Docker would be, but why I need Docker? Why I should be interested in such a technology? Well, because Docker is really, really diffuse in many different aspects of the IT. And every day we discover a new task that fits really well with a containerized architecture. For example, all the test automation and continuous integration tools support Docker, Jenkins, Travis CI, and so on. Many cloud service providers give the customer the possibility to choose a Docker-based architecture for their services. The microservices world, like for example the FN framework, is based on Docker in many applications, because they use a container to modularize the function as a service techniques. The high throughput computing make a huge use of containers in order to do something like opportunistic computing and parallelizing a huge number of processes on their mainframes. And also Liferay supports the Docker deployment of their application. But what we will discuss today is how we can start using Docker, not only from the deployment phase of our project, but in the early stage of our deployment. When we start a new project, we can start it with Liferay running on a Docker container and develop the entire project with Liferay running on a Docker container without being forced to change our development habits, because we can use GoGo shell, we can use gulp watch, we can debug our application running on a Docker container, and we can do portlet deploy and so on in a really similar way, like if we are developing in a normal environment. And today I will show how to do that. If you want to try all of this dev session at home, here I published some useful links that you can find also on the description of the YouTube video, under the video here. And basically, we have a Docker for Windows application, that is this application that is running on my PC here. This is Docker for Windows, and you can install, it's free. You can install it from the official Docker site. And then we have 3 repositories of GitHub where I published my code in case you want to try this presentation. But let's start the live demo. So I will open my Eclipse here, and I will show how the Dockerized Liferay Workspace is composed. The main thing that I made to Dockerize Liferay Workspace is the creation of those 3 Gradle commands: start dockerenv, stop dockerenv, and build docker image, that allow us to manage our Dockerized architecture from inside Eclipse without the need to external applications. And I realized that those commands with a Gradle plugin here in the Gradle folder here that declares a particular task that is Docker compose and allows us to launch our containers, stop them, and publish a Docker image on our local PC. And these are made as simply calls to Docker executable commands that are exposed by Docker APIs. And in particular, the start docker env starts a set of containers that we specify into this docker compose.yml file that is under the Docker folder here in the Liferay Workspace. If we look at that file, we have a list of services that are our containers that will start when I press the start docker env. We have a Liferay portal instance here, a database based on MySQL here, an Elasticsearch standalone instance based on this image on my Docker Hub, and a Kibana standalone instance for the indexes console. If I double-click on start docker env here, Gradle tells me that it's starting our containers here, all the 4 containers. And then I can open a PowerShell here and type docker starts to see that my 4 containers are actually up and running here. Now, the main difference between a Dockerized Liferay Workspace and a normal Liferay Workspace is that I cannot see Liferay logs here on my console because I have no servers here inside Eclipse, so Eclipse isn't able to redirect the server output on its console. What I have to do if I want to see my logs is to open my PowerShell and type docker logs -f and the name of the container that I want to read. We have Kibana, Portal, DB, Elasticsearch. In this case, I want to see Liferay logs, so I select Portal. And here are the Liferay logs. Is actually starting here. So they're deploying the teams now. This is the Liferay banner that you can recognize. And it's quite done, I think. Okay. And the server end up to start. So how can I reach my container now? Because a container is an isolated set of processes. So how can I see my Liferay now? Well, here in my portal service description, I tell Docker that this container starts from this Docker image that we will see a bit later. And it exposes those 3 ports, 8000, 8080, and 11311, and binds those ports with my localhost ports. This means that if I type on my browser, for example, here, I type localhost 8080, I will see my Liferay instance running with my home page. Let's wait only 1 second, and here it is. This is my Liferay interface on localhost that is running on a Docker container. Then, if I sign in with my super secure user and password, and remove some garbage here, I'm inside my Liferay portal. Now, maybe I'm interested now into deploying something on that Liferay because maybe I have to start some project, I develop my portlets, and I want to deploy them. And for this dev.life session, I realized these sample portlets here that does quite nothing, that are render and log debug, and I can deploy it on my Docker container. But how can I do that? Well, in a normal situation, I will search for it on my Gradle tasks. Here it is, and I will hit deploy 2 times, and it will magically deploy my portlet on my Liferay instance. But how I can do that with my containerized architecture? In the same way, nothing different than usual. Because if I hit deploy and I go to that, it's not finding my theme. Sorry, I forgot to change the theme to my Liferay. I will do it in a moment. To restore the classic theme in order to avoid garbage on logs, because it could be difficult to look at interesting things. Okay. Then I go back to my welcome page. I clean my portlet. Okay. I redeploy my portlet here. Okay, and here we have the stopped and started portlet deployed on my Liferay. If I come back to my Liferay instance and hit plus, I can see my dev session sample portlet here, and I can add it on page, and voila, it has been deployed. So deployment, cleaning, building, and so on are the same as a normal environment. Why? Because here in my Docker Compose file, I told my Docker container to share my deployment folders, OSGI configs, deploy, OSGI modules in this case, with my file system. So the containers can see my file system, and they can see modifications on my local file system and react to them. So I deployed my portlet on my local folder here. This portlet is here on my local file system. The container watched this new module and deployed it on Felix, so I can see my portlet deployed. But I have 4 different containers, so I can also type here, for example, localhost 5601, and I can open my Kibana container, and I can see here the Liferay indices on the Elasticsearch container that is up and running in parallel with my Liferay container. And I can also connect to my MySQL database through MySQL Workbench if I want, because my DB container is listening on port 3306, and that port is bound with my local host. So I can do all the things in the same way I will do it in a normal environment. And that's okay. But what if I want to debug my application? Because normally I will hit this button to debug to start my server in debug mode, and then I place breakpoint on my code, and then I can debug my application. But if I place a breakpoint here, it doesn't work because my server is running on a remote container. Well, to explain to you how to debug application in a container, I will first show how those containers are built. We have basically 2 containers. This called Liferay Portal 7.0 CEGA5 is a production-ready container that exposes only the 8080 port and nothing more than that, does not use any volume, and installs only a telnet client to be able to reach the local GoGo shell from inside the container. So it has the minimum set of dependencies he needs to run, and no more than that. But if I want to develop, I need more than that, because it's not possible to develop with such an isolated environment. So in my development version of the container that inherits from the production version, I expose also the 9999 port for JMX. I expose the 8000 port for JPDA, and I enable a JPDA socket for the debugging purposes. And I expose the 11311 port for the GoGo shell that we will see in a moment. But since I exposed the JPDA on my container, if I want to debug my Liferay, I just have to go here, debug configuration, and set up a remote Java application. If you can read here, remote Java application debug configuration. I select my project, in this case, dev session sample portlet. I type localhost as the host that I want to reach, 8000 as the debug port, and I hit debug. And now, if I go to the debug perspective in Eclipse, I can see my debugging session here open. And if I open my Liferay and hit refresh, I can see that here the debugging is working as usual. And I can see here all the objects, the stuff like that. I can debug, and I can run it when I finish the debug. But leaving remote debug always on can be quite heavy for performances. It can it's a really heavy process to be maintained. So If I don't need to debug my application, I can hit the disconnect button, and then if I put another breakpoint here, it will not work because the debug is switched off. And when I need it again, I can go here, hit dev session sample portlet configuration here, and then debug will start again to work as expected. So this is a different workflow with respect to a normal debugging workflow with a local Liferay environment, but it's not so hard, in my opinion, to implement this way to debug applications. And it can be also a bit more performant than a normal server started on debug, because here I can activate debug only when I really need it and leave it switched off when I don't need it. So my server can be a bit much performant. Then another fantastic tool that I would like to use with my Liferay development sessions is the GoGo shell. The GoGo shell can be activated here from putty. I can open a local instance of putty, and I should connect on localhost on port 11311. And since I exposed here my 11311 port, this should work correctly, but it's not so easy to make it work. Why? Because Liferay default property, module framework property OSGI console, this property, has a value of localhost 11311. So only local connections to the GoGo shell are allowed. In order to enable my local host machine to connect to the remote 11311 port of my container, we have to change this property to this new value, 0.0.0.0 column 11311. And with this property enabled, it works correctly. How we can include these portal Docker properties on our development container? With this configuration on setenv.sh. We, in this container, enabled JMX and added two external properties file. One is the classic portal developer properties, so that we can have Liferay running in developer mode, and the portal Docker properties, so we can access to the GoGo shell from a remote host like our local machine. And if I open this GoGo shell, it works perfectly. I can type lb pipe app dev session, and I see my dev session sample portlet correctly deployed in active status with an ID of 515. So my GoGo shell works correctly, also with Liferay running on a Docker container. Then, the last beautiful feature that was introduced on Liferay 7.0 team development workflow is the gulp watch. I find it really useful for every front-end developer, because it allows you to modify your SCSS files and see your updates live on your browser page without having to reload the browser page, without having to deploy anything, but only hit save on your SCSS file. And this is a really nice to have feature, but unfortunately this doesn't work natively out of the box when Liferay runs on a Docker container. And I will show you this in this part of my demo. I created here a dev session sample team with Yeoman Liferay team command. And here we have the Liferay team tasks that only includes gulp, because all this part is commented, and I will uncomment it a bit later. But this is the default configuration of our gulp file.js when we create a new team SDK. With this configuration, if I open a console on that folder, let me only open this console to show you this. Okay, I open here a PowerShell and I type gulp watch. Make it a bit, because I want to show you also the Liferay logs together, so I have to put them in the same window here. Okay, this is the Liferay logs console. Okay, if I hit here gulp watch, it should try to deploy my team on the web bundle build folder and then connect the Liferay load application on the server to my client host. And it tries to deploy the team to the GoGo shell. So the deployment to GoGo shell works because GoGo shell is exposed on 11.3.11 port, but I can start it and I can show you that he cannot see the web bundle build deployment folder because it's not on his file system, but it searches for it on my local file system. And here it is. The final found exception because it searches the web bundle build folder on my local file system. And this cannot work because the Docker container cannot see my local file system instead of the portions that I allowed him to see, and with different path. So this path will never exist on my container. But since I think that this gulp watch is a really good feature, and it's a pity to lose it, I realized this Docker gulp task for Liferay npm library that you can download from npm. And if you enable those two lines on your gulp file.js and you install it with npm install save dev copy paste is not working now. Too easy. If you install it in this way with npm install, then you will be able to use gulp watch with Liferay running on a Docker container. So if you notice, now we have our Docker gulp task for Liferay on our development dependencies here on package.json, and we enabled it on hook modules, and we have also to write here in this Docker container name the name of our Docker container, the Docker container in which Liferay is running and in which the package should be deployed. In our case, this is the Liferay portal 1 container. So now I will try to show you the gulp watch working with Liferay Docker container. I type gulp watch here, and we should see that now the Liferay team is correctly deployed on our container on this black screen. Okay, and here it is. Then I can come back to my Liferay instance, and I can configure my public pages to use my new team, the dev session sample team here. I select it and save. And you can see that we did some huge modifications to the original theme because we had this Liferay name yellow instead of white. Now, I can try to show you Gulp Watch in action, but I have to set up my Windows in a, because I cannot use, I normally use two screens, but I cannot share two screens, so I have to make Tetris with my Windows in order to, not this, turn this, this one. I have to make a sort of puzzle with my Windows in order to show you all the three pieces of Gulp Watch flow. Okay, and here we have. So we have this line on our custom SCSS that tells Liferay to paint yellow the Liferay link on the footer. If I set it to be red in this way, and I hit save, the Gulp Watch will be triggered, and if I activate the live reload here on my browser, it should deploy my modification to the server, and the server should trigger the update and tell my browser to color in red the Liferay name there. I can try to do that with hitting save. You see that the Gulp Watch is running, is copying files on Docker. He's deploying the modification, and I should see my no, something went wrong, like always. I can try it again. So I activate Gulp Watch. Okay, it's working correctly. He's copying files on Docker here. I hit save. It's building my... Okay, wasn't working for some strange reasons that we all call demo effect. But now it worked correctly. I can try it again. I will follow the Liferay name in green, and it should work the same. I hit save, he runs, compiles, copies, and then the Liferay becomes green. Okay, demo effect defeated. So this feature is possible because we basically make a two-step copy of our theme file. So first we copy them to the web bundle build folder on our local file system. Then we attach our custom hook module that copies the modified files from the folder on our local file system to the folder on the remote container. Then live reload running on the remote container listen to the modified files and tells the browser to reload the modified files, and so it can work correctly. This seems to solve also another problem that I had with Windows, because on Windows some Gulp Watch runs triggered an eperm error because Gulp Watch was trying to delete and recreate some files that were owned by Liferay process. So Windows locked out badly, and we were forced to switch off the entire Liferay application. Then we deleted manually those files, and then we had to restart Liferay again, and we could restart to use our Gulp Watch. It was not so good. But with Docker container, this error has disappeared. So it's another beautiful thing about Docker container. Well, the last thing I want to show you in this demo today is how to create a fresh Docker image of our actual state of development environment. So in our case, I deployed portlet here on bundles, OSGI modules. Yeah, I can deploy also my theme here with deploy. And this should go to the work folder here. I can see it. I cannot see it on my work folder. I don't know why. Maybe something went wrong. Bundles deploy. No, it could be. It should be here, but I can see it. So I try to deploy it from Gradle. Okay. Okay. Let's see if now we can see it. There's some issues with deployment process on my Eclipse. Let's see if okay, Eclipse is not refreshing. I don't know why the file system, but here in Docker Liferay Workspace example, Liferay Workspace bundles SGI war, there is actually this folder. We have our dev session sample theme.war, so it worked, but Eclipse strangely doesn't work correctly in something.
Maybe you need to refresh the Eclipse project.
I can try. I can try to refresh both these and these. Let's see if SGI. Okay, yes, now I can see it. Thank you. And now I can hit this build Docker image to build up a Docker image of this environment. This Docker image is based on this Docker file that we have here. That is a really basic Docker file because it just copies files from our deployment folders to the respective folders on the container. You can do even more complex things like multi-stage builds with Gradle-enabled containers to build your files on the fly. You can do whatever you want, but the beautiful thing of this build Docker image feature is that you can version your environment, not only your code, but also your environment, and then you can use this container for whatever whatever you want. Like we deploy deployment or test automation with Jenkins or Bamboo or something like that. Or you can send it to your customer Docker registry and manage it in production with Kubernetes or another Docker orchestrator. You can do whatever you want. And in this simple case, we will only try to run this container to see that it works. This container iterates from the production Liferay container, so it hasn't the debugging enabled, it hasn't the GoGo shell exposed externally, because we don't want that our container in production expose more than they are forced to do for security purposes. Now, to demonstrate that it actually works, I will stop my Docker environment here. I will open my Docker Compose, and I will substitute this image with my new container that is called the Liferay Portal Dev Session. I will disable those ports because they actually will not work because they're not exposed, and I remove the file system sharing, with the exception of the Liferay document library that is in a Docker managed volume, and then I restart my Docker environment. Okay. Now, the Liferay container that is actually starting here will be independent from the file system of my local machine, because it will have both the portlet and the theme deployed into the image directly. So if I cancel my files from these SGI folders here, I will see them on my container when it comes to life, because I deployed them into the container itself. And as I said before, this is a really simple example, quite useless, because I could share my files with the container and it will be the same. But it's a beautiful example of what you can do with Docker. You can use them to make easier your development processes, and you can also use them to propagate your environment from your local machine to wherever you want. Also, if your customer wants, also in a production environment. Now it's my container is starting. We can give it a little more to start our modules. Okay, we are almost done. We are almost done, I think. Okay. Here is our theme that has been deployed on our container. It's now deploying the standard Liferay themes. And it should be done in seconds. Okay, here we are. So we have our running Liferay container. If I try to connect to local GoGo shell, here I can't because it's not exposed. But I can connect to the GoGo shell directly from my container with Docker exec. I'm launching this command inside my container, so I can see the GoGo shell. But to launch this command, I must have the Docker privileges in order to launch, to execute commands inside containers. And then I can do lb pipe dev section, and I see my two plugins deployed. Also, if I remove them from my file system, because I don't have them here anymore, no more. So we are totally independent. And if I go here and refresh the page, I will probably need to reconnect inside my Liferay. But here I have my portlet, and here I have my custom theme with Liferay in green. And with this demonstration, I finished my live demo, and I thank you all for the attention. And if there are some questions, I'm here to try to answer.
All right, thank you, Iacopo. It was a pretty interesting one. I'm looking at the Slack channel. I don't see any questions right now there. If you guys have any questions, please type them now. Looking at the YouTube chat as well, and no questions there. I don't know if you shocked everyone or they are just downloading your stuff and trying it at home. But I have a question, which I'm going to ask in the meantime. The Gulp Watch thing integration, is it an operating system specific, or it should work on, because I saw some like file paths with like C and Windows specific stuff. I assume that's just because you use Windows, but it should work on any other operating system, right?
Well, the idea is that it should work with any operating system. The C column path was related to my local file system, and in particular, it is this one, or liferay.theme.json, because he tries to reach the web bundle built on this path as a default behavior. So this is the path that you have seen on the container. I tested it only on Windows environments because I use Windows and I can't test it on other environments. From a theoretical point of view, it should work, but I will be very happy to have some confirmations of that about some users that maybe try to use it on different operating systems. And if there are some issues, I can maybe try to solve them.
Right, so that was going to be my next question. Is like we have like I don't know, tens of people watching you now. Maybe someone's going to try it on Linux or Mac OS. And what's the best way to reach back to you if they discover any issues or want to help you in any way?
Well, they can leave a comment under my blog article on Liferay blog posts, or they can use the GitHub issues channel
on your project.
On the project, that is this link here, the last link, this one.
All right.
For the
we have a question, and the question is: have you tested it with DXP?
No, unfortunately not, because I'm not a DXP user. But also, this is the same as for the other operating system. If someone with a DXP Liferay version can test it and tell me if he finds some issues or something like that, I would be happy to investigate them.
Okay, and there's another question. Did you try Blade deploy for the other modules?
Blade deploy?
Blade deploy.
No, I never tried Blade deploy, but we can try it live and see if it works.
Okay, I think you probably gonna have to do some switching now because you don't have that image running.
Yes, I have to. Yes, because I have the contact.
Okay, maybe we can try that later and answer that offline.
Yes.
Okay, and there is another question. Do you have any experience with production Docker deployment, and especially environment scaling, dynamically adding new modules, managing licenses, etc.?
No, not for the moment, because we arrived in my company only to the development environment. Our customers are not ready for a Docker production environment yet, but I think that we will be forced to do that sooner or later, because all our customers are curious about Docker, are interested in Docker, but as all new things and all unknown things, they fear it a little bit for the moment. But if I will have some production experiences with Docker and Liferay, probably I will write another blog article on that.
That would be nice. Also, to everyone listening, watching out there, if you are doing interesting stuff with Docker in production and you want to share your experience, just get in touch with developer relations team at Liferay. We can arrange you a session in dev.life so you can tell us how you do stuff with Docker and Kubernetes in production, for example. All right, let me see. I see another question, but it's more of a question to me rather than to you. It says IPO projects offer a Docker image for quick start. Are many internal projects starting to use Docker? Honest answer, I don't know. I would assume, I don't know which projects are using Docker, and there may be projects using Docker, which I don't know they're using Docker. Definitely WeDeploy uses Docker. So yeah, we do use Docker whenever it makes sense. It's not to say that we are now going to be using Docker everywhere for everything, but if it makes sense, yes, we will. Okay, let's see. Slack, no more questions on Slack. There is nothing on the chat. Okay, so Iacopo, thank you very much. Very, very interesting session. Let me switch back to my screen because I have an important announcement to make to those of you who are still with us. And the important announcement is about the next session. If you like Docker, then maybe you will like the next session. And I'm happy to tell you, you're the first to know, our next session is going to be on April 6th. And it's going to be about building truly serverless mobile app with WeDeploy and Kotlin. So stay tuned. It's not announced on Meetup yet. It will be soon. As I said, you're the first to know. Enjoy. I hope you enjoyed this session. I hope you're also going to join us with Victor Oliveira, who's going to tell you how to build stuff with WeDeploy and Kotlin. And until then, thank you very much for joining us, and see you next time. Bye.
Bye-bye.